Hello everyone. Today I will going to start rolling motion and rotational kinetic energy of a rolling body on a horizontal surface and on a inclined plane. Here see rolling motion. Yesterday I have discussed already. These are the key points. Suppose consider a wheel. Okay, when it is rolling on a rough horizontal surface, the friction was not considered here like this. Okay, center of mass is moving like this direction, the velocity VCM, and it is rolling like this with an angular velocity omega, with an angular acceleration alpha. Okay, at this point of contact, what happening is that here R omega will acting backward and VCM will acting in the downward direction is already known. Okay, for the pure rolling, what are the conditions for pure rolling? For pure rolling, what are the conditions are applicable? VCM minus R omega is equal to 0. VCM is equal to R omega. These conditions are valid for pure rolling. Okay. Next, what is the acceleration of the center of mass? The acceleration of the center of mass ACM is equal to ACM is equal to R alpha. This alpha is equal to ACM upon R. So these conditions are valid for the pure rolling. Okay. These conditions are valid for the pure rolling. Yesterday I did discuss about this concept very detailedly. Today I will going to explain some problems based on the concept of this pure rolling. Okay. Yes. See. Suppose consider what is that a wheel. This is a wheel. Suppose consider a wheel here, beta. This is a wheel. Wheel has a mass m. Wheel has a mass m and radius r. It is placed on a moving platform here, beta. Moving platform. It has a mass m and radius r. It is placed on a moving platform. This is a moving platform here, beta. A moving platform. Moving platform ऐसे है. तो moving platform है बेटा. Moving platform ऐसे. Moving platform ऐसे है. Okay. So the uppermost platform is moving with a velocity of 2 meters per second, 2 meters per second, and the lowermost platform is moving backward direction with velocity of v is equal to 3 meters per second. Let's take radius of the wheel is equal to 1 meter. It's the radius. The radius of the wheel would be equal to 1 meter. Radius of the wheel would be equal to 1 meter here. What is the radius? Radius of the wheel is equal to 1 meter. So imagine that. Assume that the rolling is nothing but a pure rolling. It is the rolling is nothing but a pure rolling with an angular acceleration alpha. Imagine the body is rolling, pure rolling on between the platform. It could not be slipping. Okay. So find the angular velocity and linear velocity of the body. Find the linear velocity and angular velocity. Angular velocity. The body is shown here. Find the linear velocity and angular velocity of the body. I showed it clearly. This is one of the platform. It is moving backward direction with a velocity of 3 meters per second. And this platform is moving forward direction with a velocity of 2 meters per second. Then the wheel is rotating like this. The wheel is rotating between the platforms. So when the wheel is rotating like this, so what is the linear velocity? What is its linear velocity? Linear velocity is how much? So what is its angular velocity? Angular velocity is omega is equal to how much? That is we should have to calculate now. Okay, here see. At this point, V7 is greater than the velocity of the center of mass is moving like this direction here, beta. And this point of contact, what happening is that R omega, which is acting downward direction. Okay, but the platform is moving like this direction at this point. Therefore, R omega is greater than to VCM beta. The point of contact, imagine that the VCM, when the VCM shifted from this point, its magnitude and direction does not change. Already know from the vector loss. Okay, so here 3 meters per second is moving downward direction. This plank is moving backward direction, and R omega will also act in this direction, but V7 is acting in this direction. Therefore, at this downward plank, let's say this is a plank 1 and this is a plank 2. For the first plank, it is very clear that for the first plank, it is very clear that what is happening is that R omega plus 3 is equal to VCM now. R omega plus 3 is equal to VCM को बराबर हो जाता है बेटा दोनों का, because of R omega will act in downward direction. Velocity of the plank is also moving backward direction. The sum of these two values which is equal to VCM because of it is rotating between the planks. Okay. So from this VCM R omega is equal to what is that? R omega minus VCM is equal to क्या हो जाता है बेटा? 3 हो जाता. That is equal to 3. That is equal to क्या हो जाता है बोलो? 3. Let's take this equation number 1. Whereas in the second case here see at this point for the plank 2, for the second plank it is very clear that what is that? VCM minus R omega is equal to 2 है ना? Let's take this equation number 2. So from these two equations now we should have to calculate what is that VCM and R omega. These two values now we have to calculate here. Okay, right? Okay, solve 1 and 2. 1 plus 2 to do 1 plus 2. 1 plus 2 implies what happening is there. See here. VCM minus R omega minus VCM है बेटा इसमें तो प्लस VCM माइनस VCM हो गए हैं तो इधर this प्लस R omega हो जाता है बेटा सेकंड केस में. What would be gets cancelled out? See here. VCM gets cancelled out. 2R omega is equal to what is that 5. Okay. So R omega is equal to 2 into R value is the 1 given into omega is equal to 5 है बेटा. That is omega is equal to 5 upon 2. That is equal to 2.5 radian per second square. The value of omega. Okay. Next, see this value substitute or 5 by 2 value substitute in equation 1 or equation 2. No problem. You will get 2 implies what you will get VCM. What is the VCM value? VCM value we have to calculate now. VCM plus R omega. R value was given 1 into omega value is the 5 by 2. That is equal to 2. This value is equal to no. Therefore, VCM is equal to 2 minus 5 by 2 हो गया. ठीक है. 2 minus 5 by 2 means VCM is equal क्या होगा बेटा? VCM is equal to 4 minus 1 by 4 minus 5 by 2. That is VCM is equal क्या होगा बेटा? Minus 1 by. So the center of mass value is equal to VCM is equal to what is that? Minus 0.5 meter per second है. So its velocity would be equal to what is that? 2.5 meter per second square. VCM is equal to minus 1 by 2 means it is not moving forward, it is moving backward direction. Is it clear? It is not moving forward direction. Minus value represent that it is moving backward direction with a velocity of what is that? The velocity of particle should be equal to 0.5 meter per second. Is it clear? Is it clear or not? Hello? Okay. This is a previous IIT problem. Both are sunny. Next problem देखो here. Suppose consider a one solid sphere है बेटा. This is a solid sphere. Suppose consider a solid sphere. This is a solid sphere. Okay. The solid sphere is placed on a rough horizontal platform. Suppose consider a solid sphere beta, solid sphere. The solid sphere is placed on a rough horizontal surface. This is a rough horizontal surface, like this. Rough horizontal surface beta. Okay, this is solid sphere. Also sphere, solid sphere, not this beta. This is solid sphere having a mass m and radius r. It has a mass m and radius r, which is placed on a rough horizontal surface. This is a rough horizontal surface. Horizontal surface. Okay. At the topmost point, at this point, at topmost point, what happening is this: the force of F newtons is X. The force of F newtons is X. Then when a force of F newtons is X over the top of that sphere, then the sphere can be rolled like this. The sphere can be rolled with respect to center of mass. The sphere can be rolled like this. The sphere can be rolled without slipping. The sphere rolls. The sphere rolls without slipping. Without slipping. Without slipping. Then find the acceleration of the center of mass of the. Find ACL is equal to solid sphere beta. What's the sphere? Solid sphere. Solid sphere. Solid sphere. So find the acceleration of the center of mass as shown in the figure. Find the acceleration. Find the acceleration. Find the acceleration of center of mass of the sphere. The sphere as shown in here. It's shown in here. So find the acceleration of the center of mass as shown in the figure. Yes. When a sphere is rolling like this, okay. When a sphere is rolling about this axis of rotation, the axis of rotation would be acting perpendicular to the plane like this. Okay, this is an axis of rotation. This is an axis of rotation. The axis of rotation which is acting perpendicular to the plane, and the sphere is rolling like this on the horizontal surface like this. Okay, the center of mass is moving like this. That means the center of mass is moving along the tangential direction like this. Okay, so in this case, you have to calculate what is the acceleration of the center of mass. Okay. So on the sphere, how many forces are acting on this? This is a rough horizontal surface. Okay. So rough horizontal surface is better. That's what happening is there from the point of contact, the frictional force will act. The frictional force will act backward direction, and upward force is already acting like this forward direction. Okay. Let's take what is the radius. The radius of the sphere would be already given R. R है बेटा. The radius of the sphere would be R. This is okay. It has the two types of the motions. First one is center of mass is moving in linear. Okay. Second one is the wheel is rotating. That means it has two types of the motions. One is a linear motion, and second one is a rotational motion. The wheel has the solid sphere has the two types of the motions are there. First one is it is rotating like this. That means center of mass is moving linearly. The center of mass is moving linearly like this. Okay. And second case is the wheel is rotating like this. When the wheel is rotating like this means it has a rotational motion. It has the two types of the motions. So first case in case of linear motion, see for linear motion, for linear motion, torque tau is called what is torque tau? Torque tau is called I alpha, no? For linear motion, the torque acting upon this point is given by torque tau. Torque tau is equal to force into perpendicular distance is equal to I alpha. Torque tau is called I alpha. Okay, torque tau is called I alpha. But when the wheel is rotating in a circular path, but alpha is called what is alpha? But alpha is equal to A upon R is beta. Therefore, F cross R is equal to I value is equal to what is that? I value about this point of contact. I value is equal to what is that? I value is the moment of inertia about the center of mass of the solid is equal to 2 by 5. Okay. Next, the moment of inertia about this point of contact is equal to what is that? About this point of contact, we have to calculate what is that moment of inertia. That is equal to I is equal to about this point of in case of linear motion, the center of mass is moving like this. F plus R is equal to I alpha. That is equal to 2 by 5 into mr square into what is that? A upon R is. So R 1R gets cancelled here. Beta F is equal to F is equal to 2 by 5 into M. F is equal to 2 by 5 into M. A. Let's take this equation number 1. Next, in case of rotational motion means how many torques are acting on it? First one is applying force would be actually talked about this point of center of mass, and second one is the frictional force will actually act along this direction. Therefore, for rotational motion, how many torques are acting on it? The torque, this is a clockwise sense and this is the anti-clockwise sense. Therefore, the net torque tau net is equal to what is the tau net? Tau net is equal to F cross R minus F cross R is equal to what is that? F cross R is equal to I alpha only. F cross R is equal to I alpha. So from this, what I am taking common here? About this point of contact, we have to calculate the net moment of inertia. R common karo, F minus F is equal to mr square 5 by 2 mr square plus mr square into alpha. Alpha value is A by 2. About this point of contact, we have to calculate the net moment of inertia. What is the net moment of inertia? The moment of inertia of the center of mass plus the moment of inertia of this point of contact, which is used the point of contact of the moment of inertia. That is equal to alpha is equal to what is alpha? Alpha is equal to A upon R. So not 2 beta. Alpha is equal to A upon R. A upon R. The value of alpha is the value of I. Here, about this point of contact, the moment of inertia, I dash is equal to what is that? Let's say it is I dash is equal to ICM plus MD square is already ICM means what is that? 2 by 5 mr square because of it is a solid scale plus mr square है बेटा पूरा कितना हो जाता है बोलो 7 by 5 m or square. The net moment of inertia about this point of contact is given by 7 by 5 mr square. That is equal to R into F minus F. Frictional force is equal to it's a 7 by 5 mr square into A upon R. Is it clear? Okay. So from this, what would be the gets cancelled out here? See, what would be the gets cancelled out here? Here, what would be the gets cancelled out? On R also gets cancelled out. Okay. F minus F is equal to what is the F? F minus F is equal to what is the F minus F is equal to 7 by 5. 7 by 5 MA. 7 by 5 MA. 7 by 5 MA. Okay. Is it clear? 7 by 5 MA. So from this F value also already knows what is the value of F. F is equal to 2 by 5 MA. That is 2 by 5 MA minus F is equal to 7 by 5 MA beta. F is equal to F is equal to 2 by 5 MA minus 7 by 5 MA. That is F is equal to 5 is the common here beta. Okay. 2 minus 7 into M A. That is F is equal to 2 minus 7 means minus 5 upon 5 into M A beta. So from this A minus 5 gets cancelled, A is equal to minus F upon M A. So with this acceleration, it is moving this roller. Okay. Next, see, consider the same concept and applying the same disk beta. Okay. Suppose consider a same sphere, same sphere है same sphere है बेटा, ये same sphere ऐसे है, it's a same solid sphere, okay, which is placed on a rough horizontal surface, okay. The friction force will acting along this direction like this. Friction force Fr is acting forward, okay, and on the topmost point, a force of F newtons is applied like this. A force of F newtons is applied from the topmost point. This is what it is. This is nothing but a solid sphere only. Solid sphere. This is solid sphere only. Okay. The force of F newtons is applied at the topmost point, and friction force also acting in the bottom direction like this. And the center of mass is moving with a certain acceleration A. AC. वो भी निकालना पड़ता है. In the same case में, in the second case, friction force is acting backward direction है बेटा. But इसमें क्या हो रहा है? Friction force also acting in the same direction. The same scenario, friction force also acting in the same direction. Friction force is acting in the same direction. So in this case also we have to calculate what is the acceleration of the center of mass. Find the acceleration of the center of mass in this case. Friction force and applied force are both are acting in the same direction. Write down problem. Problem 6. Frictional force. Frictional force. Fr and applied force F. Applied force F. Applied force F. Applied force F. Both are acting in the same direction. Acting in the same direction. Same direction. Same direction. Same direction. Then find AC. Acceleration of the center of mass. This also JEE problem है बेटा. बहुत आसान है, देखो इधर. So here see, central mass, what is that? Friction force and applied force, both of them are acting in the same direction. That means the resultant force due to this, what happening is F plus Fr is equal to MA. Let's take this equation number 1. Okay. F cross F plus Fr, the sum of these two forces. In case of linear motion, the sum of these two forces would be is equal to MA. For rotation motion को क्या हो जाता है बोलो? For rotation motion को, for rotational motion क्या हो जाता है बेटा? वो भी टॉर्क एक्ट जो हम एक्ट करते हैं, वो भी टॉर्क एक्ट करते हैं in case of rotational motion with respect to this fixed point. Both of them are experiencing the same amount of the torque. Okay, that is equal to, this is applicable for linear motion. For rotation motion, see, for rotational motion, for rotational motion is very clear that what was the clear? F cross R minus Fr cross R is equal to I alpha. That is equal to F cross R minus Fr cross R is equal to I alpha beta. I alpha is equal to what is I alpha? About the center of mass, what is the value? About the center of mass. About the center of mass is equal to mr square by 2, 5 by 2, sorry, 2 by 5 mr square. About the center of mass. About the center of mass is given by what is that? 5 by 2 mr square. 5 by 2 mr square plus mr square. That is equal to A upon R. Sorry, A upon R. Alpha is equal to A by R. No? What is alpha value? Alpha is equal to A by R. है बेटा. So from this take common, R is the common है बेटा इसमें. F minus Fr is equal to क्या हो जाता है बोलो? What is the value of F minus Fr? F minus Fr is equal to क्या हो जाता है बोलो? 7 by 10, 7 by 10 है ना, 2 by 5 है. तो मोमेंट ऑफ इनर्शिया से गलत हो जाएगा. ओके, तो 7 by 5 mr square बेटा इसका वैल्यू 7 by 5 mr square 7 by 5 mr square into A upon R square gets cancelled. F minus Fr is equal क्या हो गया देखो 7 by 5 m A. Let's take this equation number 2. Okay, so from this it is very clear that 1 plus 2 करो 1 plus 2 implies 1 plus 2 means Fr gets cancelled out. 2F is equal to क्या हो जाता है बोलो MA plus 7 by 5 MA. What is equal क्या हो जाता है बोलो 2F is equal to MA 5 MA plus 7 MA means what is that 5 plus 7 12 MA upon 5 हो गए. ठीक है. नेक्स्ट A इज क्या हो जाता है बोलो A इज इक्वल टू क्या हो जाता है बोलो 10F upon 12 M. So with this acceleration, the center of mass of the sphere would be moving. Is it clear? Is it clear or not? Okay. No. Next problem, see, based on the same concept here, beta. Suppose consider what is that a solid cylinder. Solid cylinder. For the cricket ground clean करने के लिए तो solid cylinder use करते हैं ना. For the leveling of the cricket ground or leveling of the road को क्या use करते हैं? Lawn roller means solid cylinder use करते हैं. Okay. Suppose consider a solid cylinder है बेटा. This is a solid cylinder. Has a mass m. Solid cylinder has a mass m and radius r. Okay. which is placed on a rough horizontal surface. It's a rough horizontal surface. Placed on a rough horizontal surface. It's a rough horizontal surface, beta. It's a rough horizontal surface. Is it clear? A rough horizontal surface. Horizontal surface. Okay. On the center of mass, what happening is that a force of F newtons is applied like this. A force of F newtons is applied over it. A force of F newtons is applied over it. Then what happening is that it is rolling like this with an angular acceleration alpha. About this fixed point, the roller is rolling with an angular acceleration alpha. Okay. When it is rolling with an angular acceleration alpha, what happening is that, so when it is rolling like this, what happening is that the frictional force would be acting like this direction here, and the center of mass is moving like this. Center of mass is moving like this with a ACM. The center of mass also moving like this. But force ऐसा अपने तो frictional force ऐसा act कर रहा है ये. Okay, frictional force ऐसा act कर रहा है. Okay, is it clear or not? So what was this is nothing but a solid cylinder here, not a solid sphere. Solid cylinder. This is a solid cylinder. So which is placed on a rough horizontal surface. Beta. The force of F newtons is applied like this. What happening is there? The solid cylinder is rotating like this. The solid cylinder is rotating. When the solid cylinder is rotating, what happening is that on the center of mass has the linear velocity here. Beta. Center of mass is has the linear motion like this. And the point of contact, what happening is that the friction force is acting like this direction. Then what happening is that it is rolling and moving like this. Okay. So what should we have to calculate from this? We have to calculate the angular acceleration. With what angular acceleration? Which is rolling. What angular acceleration is rolling? That is we should have to calculate now. Okay. Okay. How can you calculate the angular acceleration about this point of fixed inertia? Angular acceleration कैसा हो जाता है बेटा? About this point of contact, is the acting the torque here. Okay. About this point of contact, it is moving like this. The net resultant force क्या हो जाता है बेटा? Driving force minus opposing force. What is the driving force? F is nothing but a driving force, and friction force is nothing but a opposing force. That is called what I am writing here. F minus F is equal to M A. F minus F is equal to M A. But what is the relation? What is the angular acceleration? Alpha is equal to A by R. No? Alpha is equal to A by R is already from this. A is equal to R alpha हो जाता है बेटा. That is equal to F minus F is equal to M R alpha. Let's take this equation number 1. Okay. So the torque acting on is about this point of contact. The torque acting about the point of contact is given by due to frictional force. Torque due to friction. Due to frictional force. Frictional force. Torque due to frictional force is given by tau is equal to torque friction is equal to force into frictional force into perpendicular distance is equal to I into alpha about this point. Okay. That is F into R is equal to what is I value? MR square by 2 into alpha. That is friction force into R is equal to MR square by 2. Alpha is nothing but A upon R. तो alpha ऐसे ही रखो कोई प्रॉब्लम नहीं. इसमें MR alpha इसमें भी MR alpha रहता है कोई प्रॉब्लम नहीं. ठीक है. You can write as is no problem. This is MR alpha हो जाता है ना सर. इधर अल्फा है, इधर अल्फा है, वो भी अल्फा निकालना पड़ता है, इधर गेट्स कैंसल आउट बोथ साइड्स, r into r will get cancelled out. The friction force is equal to mr alpha upon 2. Let's take this equation number 2. The equation number 1. Okay. Now equation number this value substitute here. इसमें लगाओ क्या मिल जाता है बोलो, f minus f value is equal to mr alpha upon 2 is equal to mr alpha mr alpha. तो f is equal क्या मिल जाता है बोलो, f is equal to mr alpha by 2 plus mr alpha. Okay. तो f is equal क्या मिल जाता है, f is equal to mr alpha plus 2mr alpha 3mr alpha by 2. इससे क्या निकालना पड़ता है, what should we have to calculate, angular acceleration. Therefore alpha is equal to 2f upon 3mr radian per second square. So with this angular acceleration, the cylinder will be rotated. Is it clear? Problem. Find the angular acceleration of the solid cylinder as shown in figure. Find the angular acceleration. Angular acceleration. Angular acceleration. Angular acceleration of solid cylinder. Angular acceleration. Angular acceleration of solid cylinder. Solid cylinder. Solid cylinder. As shown in figure. As shown in figure. तो इसका एंगुलर एक्सेलरेशन क्या हो जाता है बोलो, ऐसा हो जाता है, इट इज पुलिंग लाइक दिस डायरेक्शन, then with what angular acceleration it is moving on the cricket ball. कितने होते हैं, is it clear? Is it clear or not? Yes part. Okay, note करो. Next to see, suppose consider a solid cylinder है बेटा, solid cylinder. The solid cylinder is rolling without slipping on a rough or tender surface like this. The solid cylinder. The solid cylinder is rolling on a rough or tender surface. On a rough or tender surface. Solid cylinder is rolling on a tender surface. Okay. Without slipping. Slip नहीं हो रहा है. Rough